group name is Team M, and we're doing a small office local area network. My name is Elizabeth.
My name is Dahabo.
I'm Prometa.
I'm Jose.
I'm Brittany.
And I'm Rhea.
And this is our small office local area network project. And to start off, we have a table of contents just to kind of walk you through our assessment and kind of how we are navigating this project. And now I will pass it on to Prometa to do the scenario description.
So to begin, our team decided to create a local area network for a small startup company working in a compact office environment. The business has 3 employees, and each of them uses their own laptop and phone for daily tasks. Because the team is small and the workspace is limited, the network needed to be simple, reliable, and easy to maintain. Our networking goals focus on supporting the basic needs of the small office. So first, we wanted to make sure that all employees have stable and reliable internet access. Along with that, all the PCs are connected to a central network printer to keep printing convenient and efficient. Since employees also use wireless devices, we included a wireless access point to provide secure Wi-Fi throughout the office. And overall, we aim to maintain a basic level of network security appropriate for a small startup. We also had a couple of constraints to work with. Since the company has a small budget, we only included the essential hardware, meaning nothing extra or overly expensive. And because the office space is limited, our network design had to stay compact and optimized for a smaller layout. Overall, our goal was to create a network that supports daily operations while staying simple, affordable, and secure for a small startup environment. So I'm going to pass it on to Jose to cover the network topology.
So for this slide, we show the network diagram for our office LAN. We have the switch on the center, which is the main hub of our star topology. Every wired device is connected to the switch. Starting, we have the router. This device is responsible for connecting our network to the internet and providing us with firewall security. Then we have the access point that connects our wireless devices to the Wi-Fi. The office printer is also connected to the switch, so all employees can have access to the printer. And lastly, we have the 3 PCs individually connected to the switch for reliable communication. Every device has its own IP address, allowing them to communicate across the network. Now I'll pass it over to Brittany to talk about the protocols and standards.
Thank you, Jose. So standards and protocols. Starting at the application layer, our network uses DHCP to automatically assign IP addresses to all the PCs and phones. This makes it easy for devices to join the network. We also use HTTP to test connectivity, which allowed us to verify that the traffic was successfully reaching devices like the printer on the local area network. For the transport layer, the network uses Transmission Control Protocol, or TCP, for reliable communication. TCP checks for errors and ensures packets arrive in order, which is really important for tasks like accessing the printer or loading web resources. DHCP, on the other hand, uses User Datagram Protocol, or UDP, because it doesn't need the overhead of a connection and can assign IP addresses quickly and efficiently. The internet layer, we chose to use IPv4 addressing throughout the network. Our router is set to 192.168.1.10 as a default gateway, and IPv4 routes packets between all the devices, including the PCs, phones, and the printer. At the network access layer, we use Ethernet based on IEEE 802.3 for all our wired connections, like the router, switch, PCs, and the printer. For wireless devices, we use Wi-Fi based on IEEE 802.11 AX standard. We configured Wi-Fi on our WRT300N wireless router, which acted as our access point. This allowed for the phones to join the network wirelessly while still receiving DHCP addresses from the main router. For wireless standards, we use WEPA 2 PSK security to protect the network. Our access point broadcasted the SSID office and devices connected using the password group M383. We chose these protocols because they're simple, reliable, and commonly used in small office networks. IPv4 and TCP IP helped keep our addressing and communication straightforward, and IEEE 802.3 and 802.11 represent the wired and wireless network standards you would see in a real-world setup. Now I'm going to go pass it on to Rhea to talk about the hardware selection.
On this slide, I'm going over the hardware we selected for our network. We kept the setup simple and practical for a small office environment. First, we have a router which connects to our local network to the internet and provides essential functions like DHCP and basic firewall protection. Next is a switch, which connects all of our wired devices. This serves as a central point for internal communication. For wireless connectivity, we added an access point. This allows laptops and multiple devices to connect to the network without needing cables. We also include an office printer, which is shared across the network so all employees can print from their devices. Finally, the network includes 3 PCs and 3 cell phones. These represent the typical mix of wired and wireless client devices used in an office setting. Together, these devices create a complete and functional small office network with both wired and wireless access. On this slide, I'm presenting our IP address plan and explaining the reasoning behind how we configured each device. We're using the private IPv4 network 192.168.1.x, which is standard for small office environments. To keep the network organized and easy to manage, we divided devices into static and DHCP assigned categories based on the roles. First, infrastructure devices use static IP addresses because they need to stay consistent. Our router is assigned 192.168.1.1, which serves as a default gateway for the entire network. We gave the switch the address 192.168.1.2 for administrative access, so if we ever need to configure or monitor it, we always know where to find it. The access point uses 192.168.1.3. Access points require an static IP so that configuration settings like the SSID and Wi-Fi security can easily be managed. The printer is also static at 192.168.1.10, ensuring that all users can reliably connect to it without the IP changing. Next, our client devices, the PCs, the phones, are all set to DHCP. These devices can connect, disconnect, or change over time, so letting the router automatically assign addresses is the simplest and most scalable approach. Our PCs receive addresses from 192.168.1.100 to 0.02, and the phones from 0.03 to 105, which keeps the addressing clean and grouped by device types. Overall, this IP plan ensures reliability for our core network devices while keeping things flexible and low maintenance for everyday users. Now I will hand it off to Prometa for security features.
So for our network security, we chose two main protection measures that are realistic for a small startup and provide strong coverage for both wireless and internal traffic. So the first security feature we used is the WPA2 personal Wi-Fi encryption, which is the most practical for an office with 3 employees. WPA2 uses AES encryption along with CCNP to secure all wireless data and ensure packets haven't been tampered with. With WPA2 personal, all employees connect using a shared Wi-Fi password, which makes it simple and affordable to set up while still offering strong protection. This encryption prevents outsiders from intercepting traffic or accessing the network. Overall, WPA2 Personal keeps unauthorized users off the Wi-Fi and protects the office's wireless communication. Our second security layer is a combination of the router's firewall and access control lists, or the ACLs. The firewall is built into the router and it blocks any unwanted or suspicious traffic coming into the network. On top of that, we applied an ACL specifically to the printer. The ACL tells the firewall exactly which devices are allowed to communicate with the printer, which in our case is only the 3 employee laptops. This prevents guests or unauthorized devices from sending print jobs or accessing printer settings. It helps protect internal documents and prevent the misuse of the printer. Together, these security features give the office a strong but simple protection setup, which is ideal for a small startup environment. Next is going to be Brittany with the demonstration of the packet tracer.
Thank you, Pramita. For our demonstration, I'll first walk through the key devices we used in the Cisco packet tracer and the roles in the network. The main device was the Cisco 2901 router, which acts as the default gateway and runs the DHCP server. It assigns IPv4 addresses to all wired and wireless devices and connects the local network together. That's connected to the Cisco 2960 switch. This switch connects all the wired devices like the 3 PCs and the printer, as well as the wireless router that provides the Wi-Fi. The switch is the center of our star topology. For wireless access, we use WRT300N, the wireless router, which we configured to work as an access point. It broadcasts our SSID office in and uses WEPA2-PSK security with the password group M383. This allowed for the smartphones in our simulation to connect wirelessly and still receive IP addresses from the main router. We also included 3 PCs which connected to the switch and set to receive their IP addresses through DHCP. These PCs were used to run ping tests and access the network printer, which showed the routing and addressing were working properly. We also included 3 smartphones, all of which connected wirelessly through the WRT300N. Each phone successfully received a 192.168.1.x IP address, demonstrating that the wireless network was fully integrated with the wired local area network. Finally, we added a network printer configured with the static IP address of 192.168.1.10. The PCs were able to ping and access the computer, confirming the static IP configuration and wired connections to the switch were all correct. Overall, our packet tracer simulation demonstrates a fully functional small office network using both wired and wireless technologies. And here's our full network topology that we built in Cisco Packet Tracer for a small office simulation. As you can see, it displays all the devices I explained in the previous slide, like the router, switch, the 3 PCs, a printer, the 3 phones, and the wireless router acting as the access points. Now for the ping test. We wanted to show that the network is fully functional, so we ran 3 ping tests from a PC, one to the router, one to the printer, and one to another PC. As you can see, the ping test to the router confirms that the PC can reach the gateway and the router interface, and switch link are working correctly. To the right, you can see the ping test to the printer was also successful, showing that the wired path is fully operational. For the bottom left, we test the PC to PC communication. It was successful, which confirms that all devices on the local area network can reach one another. Finally, to the bottom right shows the smartphones have successfully connected to the Wi-Fi network of Office Int authenticated by WEPA2-PSK and automatically received a DHCP address. This confirms that the wireless side of our network is fully integrated. All these tests demonstrate that the entire network, both wired and wireless, is configured correctly and communicating effectively. Now I'm going to pass it on to Jose with the risk assessment.
So for the slides, we cover risk assessments for the Office network, focusing on 2 realistic risks, which are hardware failure and malware or ransomware attacks. The first risk is hardware failure, specifically with the switch or the router. These 2 devices are critical because they keep the entire network running. If either one fails, employees could lose internet access, printers would go offline, and overall productivity would drop. The impact can range from moderate to high depending on how quickly the equipment can be replaced. To reduce this risk, we suggest keeping spare equipment on site so the network can be restored quickly, and maintaining regular cloud backups to prevent any data loss. For the second risk is malware or ransomware. This usually happens when an employee accidentally downloads something harmful, often from phishing emails or unsafe websites. Malware can spread across the network, slow down devices, or even lock the company out of important data. Without precautions, the likelihood of this type of attack is moderate. To prevent this, we recommend installing antivirus software on all company computers, ensuring the router firewall is enabled, and providing basic cybersecurity training so employees can recognize suspicious links or messages before they click on them. Now I'll pass it over to Dahabo for results and key takeaways.
So here are our results and key takeaways from building the small office local area network. So firstly, our design successfully met every requirement in this scenario. All 3 employees were able to connect to the network through either Ethernet or Wi-Fi, and DHCP automatically assigned IP addresses without any conflicts. We also confirmed that devices could share files, reach the printer, and access the internet using IPv4 with the router at 192.168.1.1 as a default gateway. Additionally, during testing, TCP gave us reliable communication for things like file sharing, while UDP allowed DHCP to assign addresses quickly. Using both wired and Ethernet and 802.11ax Wi-Fi, it gave the network strong performance even with the minimal hardware. From this project, we learned how helpful DHCP and IP planning are for keeping a network simple and manageable. Packet captures in Packet Tracer helped us see how DHCP messages and TCP handshakes actually move across the network, which made troubleshooting much easier. Overall, even a small startup network can be secure and fully functional with a basic well-planned design. I will now pass it on to Elizabeth to conclude our presentation.
So in conclusion, our network design successfully meets the needs of a small office environment by delivering reliable connectivity, a structured IPv4 addressing plan, and essential security measures such as WPA2 encryption and firewall protection. These elements ensure the network is secure, stable, and easy to manage. As far as scalability and as technology demand grows, it becomes just as important as initial performance. So to support future expansion, we identified several strategic improvements, introducing VLANs to strengthen segmentation and reduce broadcast traffic, deploying additional access points to handle increasing device loads, and implementing cloud-based monitoring for better visibility, remote management, and proactive troubleshooting. Finally, adopting next-generation capabilities like Wi-Fi 6 and IPv6 will further modernize the infrastructure, increase efficiency, and prepare the network for long-term growth. Altogether, our design provides a solid foundation today and a clear roadmap for evolving the network as organizational needs continue to develop. Thank you.